Good morning, students. So we have discussed in the previous video about the Krebs cycle. Now today I'll be showing the overall equation, what is formed in the Krebs cycle and how many ATPs are produced in the respiration. As you all know, 8 ATP is produced in the glycolysis and 6 ATPs are produced in the oxidative decarboxylation and 24 ATPs are produced in the Krebs cycle. So let's see to it. Total 38 ATP molecules have to be produced. So before talking about the total ATP, let's look into this once again Krebs cycle, that what has been the starter was citric acid, right, in the Krebs cycle, and which is also called TCA cycle or citric acid cycle. Clear? So this TCA means a tricarboxylic acid, COOH group. Okay, that's why it is called tricarboxylic acid. Then citric acid cycle, why it is said? Because the starter in the Krebs cycle is citric acid. After combining with acetyl coenzyme A and oxaloacetic acid, it forms 6 carbon atom. So what happens here? Citric acid is formed with the help of citrate synthase enzyme. Okay, then the rest all the enzymes are given here. Now this here Fa3 plus is iron is utilized here, a little bit missed out. Then here cis acontic, then isocitric, then oxalo. So all this I have discussed. Then the thing is that here what happens, how many ATPs are produced, that we are going to find out. I have said in the previous video that NADH and FADH2, okay, these two are reduced coenzymes. They cannot produce the energy in the Krebs cycle. They need to enter into the electron transport chain to produce the ATP molecules. And as I have said that one NADH, it produces 3 ATP. Now let's count. Let's see in the Krebs cycle how many NADH has been produced. So here one NADH is produced here, then second one, that is here 2, then here 3. So 3 NADH has been produced here. So let me write here 1, here 2, then here 3. So when the 3 NADH is produced, 3 NADH is produced, they produce 1 NAD to 3 ATP. So 3 NADH means 9 ATP. Okay, 9 ATPs are produced now. But I have said there are 2 molecules of acetyl coenzyme A from 1 glucose molecule. So to undergo oxidation of acetyl coenzyme A, 2 molecules, they need to enter the Krebs cycle, rotate twice. So that's why 2 times. So you multiply these 2, then you will get 18 ATP. Fine. Now let's see to the next coenzyme, reduced coenzyme. It is just like NADH. It cannot produce the energy in the Krebs cycle. It needs to enter into the electron transport chain. So the electrons and protons will flow into the electron transport chain in the presence of oxygen. Finally, they release the ATP. So this FADH2, they release 1 FADH is 2 ATP produced. Okay, so this 2 ATP. Now 1 FADH in one cycle, they need to rotate twice. So 2 FADH. So 2 FADH, let me rub this one. 2 FADH is equal to 4 ATP. Fine. Now I am going to circle this one, which I have to add it. Here 18, here 4. Fine. Then next is 1 GTP has been produced here, and it is equal to 1 ATP. So this has been directly produced without the help of electron transport chain. So this 1 ATP, you will add it here So 1 ATP means twice it has rotated. So you will write here 2 ATP. So I am going to circle this one also. Now you can see in the Krebs cycle, in the beginning class I have told that it has 18 plus 4, 22, 22 plus 2, 24. So 24 ATP molecules are produced in Krebs cycle. Now let's look into the acetyl oxidation decarboxylation. Oxidative decarboxylation from pyruvate to acetyl coenzyme A. Here also reduced to coenzyme is produced. So this has been 1 NADH, right? So here also there are 2 pyruvate molecules to convert into 2 acetyl coenzyme A. Here, because 2 pyruvate molecules are formed from 1 glucose molecule, as you will know. So this 1 NADH will be counted as a 2 NADH. So let me rub this one. So this is for Krebs cycle. ATPs, total ATPs produced in Krebs cycle. Okay. Then total ATPs produced in oxidative decarboxylation. This process takes place just before the Krebs cycle. In oxidative decarboxylation, there are 1 NADH produced in one cycle, so it will be 2 NADH. So 2 NADH, we count it as 1 NADH is 3, so 2 into 3, so 6 ATP. So 6 ATPs are produced here. Now, you total this one, 24 and 6. Correct. This will be counted as what would be after the glycolysis. So this total in Krebs cycle, oxidative decarboxylation 6 ATP. Now you add it. So you 24 plus 6, this will be 30 ATP. Now in the previous video about the glycolysis, I have said that 8 ATPs are produced. So that 8 ATP produced, now added 38 total. 38 ATP has been produced in the respiration. So you have studied that in respiration means breakdown of glucose which takes place in the presence of oxygen to release carbon dioxide, water and energy. So that energy will be released and in the form of ATP. This will be 38 molecules of ATP. So this is how we got the overall total ATP. So to show that 8 ATPs are produced in the glycolysis, in the previous video, please watch that one. You will understand how many ATPs are produced in glycolysis and how are the reactions taking place in that. So here in the glycolysis, glucose is the first one needed for the respiration to take place. So this glucose will be converted into glucose 6-phosphate because there are 6 carbon, 4, 5, 6 carbon atom and the phosphate will be added here. Fine. Now here the glucose 6-phosphate will be isomerase to fructose 6-phosphate. So with the help of isomerase enzyme. So in short I will be telling here, and here it is hexokinase enzyme. Okay. So here you want to when the phosphate has been added here, the ATP has been utilized. Here the ATP I have invested here. So all this process I have discussed in the previous video. Please watch it. So here 1 ATP has been utilized here. Then here again to add 1 phosphate again, fructose 1,6-phosphate. Means here 1, 2, 3, 4, 5, 6. So phosphate was added here in the 6th one, then first one also. Why? It is isomerase to fructose 6-phosphate because fructose has 2 side ring. but glucose has one side of it. So that's why they have been isomerized. Then here with the fructose phosphate enzyme, we have utilized here to form fructose 1,6,5 phosphate. So I'm not going to explain the process. Just you see to it what happens here. The next is that this 6 carbon atom, this will be split into 3 carbon atom each. That is DHAP, dihydroxyacetone phosphate, then phosphoglyceric, wait, DHAP and okay. This we call glycerol dehyde phosphate. So I'll be writing in short, okay. Glycerol dehyde 3 phosphate. Now this glycerol dehyde 3 phosphate, it will be converted into 3 phosphoglyceric acid, because when the oxidation takes place in the what we call the aldehyde, it will be converted into acids. When the acids undergo oxidation, it will be converted into carbon dioxide. So this process I have explained. Then 3-PGA, then next will be forming 1,3-PGA. Then the next, that is phosphoenol pyruvate. Then finally pyruvate acid. Okay. So this same process will be repeated here, because they are interconvertible and they are isomer of each other. Means aldehyde and ketone are isomer of each other. Now you see the same process, that is 1,3-PGA. Here again phosphoenol pyruvate and pyruvate acid. So here the ATP is utilized here, and also here phosphate has been added again on the first carbon atom. So here also you will say the ATP has been utilized here. So 2 ATPs are invested here. 2 ATPs are invested. So that's why it is called investment phase up to here. Then from here to here, that is called payoff phase. That is because here between this glyceraldehyde 3 phosphate and phosphoglyceric acid, here what happens, dehydrogenation take place. So NAD plus is picked up by hydrogen is picked up by NAD to produce NADH plus H plus. So here one NADH is produced. So that means here also same process will take place. NADH will be produced. Okay. Now one more ATP is to be produced here. So here when the 3-PGA is converted to 1,3-PGA, that is phosphate has been added here. Means there are 3 carbon atom here, and here phosphate was at the 3rd place. Now one more phosphate is to be added to form 1,3-phosphoglyceric acid. So here 1, 2, 3, here phosphate added, and here also phosphate added to form 1,3-phosphoglyceric acid. Now phosphoenol pyruvate is formed. Now between this phosphoenol pyruvate and pyruvate or pyruvic acid, between these two, one more ATP is produced. Okay. So how many ATPs are produced now in this cycle? Let's see about only one thing, that is here 1 ATP, here 1 ATP, then 3 ATPs, because 1 NADH is equal to 3 ATP. Then so 4 ATPs there, and here one more, that is 3-PGA to 1,3-PGA. Here also ATP has been produced, 1 ATP, because phosphate has been added to the first carbon atom. So now these 3 are the payoff phase. Means how many are shown here? Let me see. So how many ATPs are produced here? Here 1 ATP. Okay. Here 1 ATP. Here also 1 ATP. Okay, I am taking from one reaction, but this is taken as twice. Okay, instead of taking separately, I have taken it twice, so it will be multiplied by 2. Clear? Then NaDH here 1, so that will be also counted as 2 NaDH, because I have always said in the glycolysis, whenever the product from the fructose 1,6-biphosphate, it has been split into 2, but the reactions formed from DHAP and G3P will be the same. So instead of writing and repeating the steps twice, we are just counted it as 2. Okay, so 2 you multiply, so this is 2. Now 1 NaDH is 3, so you multiply by 3, then you will get 6, then 2, then 10. So 10 are there. So 10 is what we call payoff phase. This is called payoff phase. So what is the net gain of ATP now? That is, we have to minus this one. Here it is 1 ATP, and here also there is 1 ATP. So 2 ATP. So net gain ATP produced in this glycolysis is minus 2 ATP. So 8 ATPs are produced. I hope you are clear of these ATPs. Now, see here, this glycolysis is 8 ATP, right? Now, I hope you understood how the 38 ATP has been produced. That is 30, what we call the 24 ATPs are produced from the Krebs cycle, and 6 ATP are produced from oxidative decarboxylation, and 8 from glycolysis. So total you will get 38 ATPs produced. Now let's see the reaction. The chemical equation which is formed in the Krebs cycle. Okay. The first is 2. I am taking everything 2 because 2 pyruvate molecules has been formed from the 1 molecule of glucose. So everything will be counted as 2. Fine. So instead of writing as 2, I want to make it clear by doing it rotating once in the Krebs cycle. Okay. So let's see with the 1 rotation. Okay. With the 1 rotation, then pyruvate first will be acetyl coenzyme A is produced here, 1. Then next is NADH. So how many NADH were produced? That is 3 NADH were produced, right? So 3 NAD plus. Fine. Then how many FADH has been produced? That is 1 FADH. So 1 no need to write. 1 FADH plus. Okay. Then FAD plus. Then after that, what is utilized? That is water. So water in the Krebs cycle, there have been 4 molecules water have been formed during this cycle, which I have shown in the previous video. So that is 4 molecules of water. Okay. Then GTP also include, that is plus 1 GTP plus inorganic phosphate 1. Now you see here what are the products formed here. Which are the products formed here? As you know easily, acetyl coenzyme A has been formed. That means coenzyme has been removed from here and coenzyme has been added during the alpha ketogluteric acid when it is converted into succinate coenzyme A. Okay. So here coenzyme A also you added. So 1 coenzyme A here. Then what else is the production here? That is NADH also is there. Then carbon dioxide decarboxylation has been taken place in the left side of the Krebs cycle, right? So that is twice. So you will write here 2 carbon dioxide released here. Then NADH was reduced to 3 NADH plus 3Hs plus, then FADH2. 3Fa, this was 2FADH2 has been produced, right? So we will write here only one FADH2, so one you write. Then molecules of water, only one water has been removed during the cycle, that is the starting cycle, that is during the Aconitis enzyme has been added into that. So that is water. So water has been removed here, right? So the water is produced here. So how many? Now it has to rotate twice. So when you rotate twice, you include now 2, multiply by 2, everywhere you multiply. This also you multiply by 2, here also 2, here 2, here 2, everywhere you will multiply by 2. Okay. Now after multiplying by 2, I am rubbing this one. 3 2s are 6. So 6 I got. Now next is what? Only 1. So here I will be writing 2 FAD. Then next is 4 into 2, 8. So 8 water molecules are formed. Then here 2 multiplied by 2. So 2 GTP produced and 2 inorganic phosphate produced. Then here 2 are the formed here in the Krebs cycle. Then carbon dioxide 2 into 2, 4. Okay, so 4 it will be counted. Then 3 into 2, 6. Then FADH2 just 2. Then here multiply by 2, 1 into 2, 2 molecules of water. So this is the overall reaction of the Krebs cycle. So I hope you understood the concept of glycolysis and Krebs cycle. And if you want more videos based on that, we can explain it in a biochemistry level. Biochemistry is a subject. It's very nice, important, and very good at future when you choose this subject, because after +2 you can choose the biology in the branch. There are various branches of biology, so you choose the biochemistry, then you can take the subject of biochemistry. And in the biochemistry level there are different chemical formulas to be explained more in glycolysis and Krebs cycle. So if you need more videos, keep encouraging me. So thank you. That's all for today. Have a nice day.